Good day, students. My name is Edo Triumph, your contact tutor for Computer Studies, Advanced Certificate in Secondary School Education, ACS CS11. I welcome you to this academic year 2018. What are we going to have today? Today, we are going to have examination-based content class. Examination-based content class. It means that this presentation is going to covers the April, August, and November examination. So I'm going to guide you what to expect, how to approach the examination. As I said in my preamble, in my introduction, this presentation is for Advanced Certificate in Secondary Education, Computer Studies. This presentation covers April, August, and November 2018 examination. So there would not be any other examination-based presentation for 2018 except this one. So everything in this presentation has taken care of everything in April, August, and November examination. Are you there? Now sit down while I take you through this presentation. One thing I want you to get, my beloved student, this presentation is not a scope, it's a guide. So I don't want you at the end of the day and say, Mr. Edu, you did not say this question is going to come out. You did not tell us this question is going to be in the examination. Mr. Edu is not here to tell you which question will be there and which question will not be there. I'm here to guide you on how to approach the examination. The examination covers the entire syllabus. So questions are selected from all the modules, all the units. So all the units in your module is covered in the examination. So don't focus on one unit, assuming that, questions will only come from this unit. No. The examination covers all the units in the computer studies module. For you to do well in the examination, it's always very appropriate to take your time, a little bit of your time, to review what we call examination question phrases or terminologies, such as state, explain, differentiate, discuss. Why do you need to do this? If you look at your study guide, the explanation, the meaning of these words are clearly explained there. Why do you need to go through this? The reason is this. If I ask you define hardware is different from discourse hardware. Because if you talk about discourse, I'm going to expect more from you than when I say define hardware. So you need to understand the meaning of these terms and phrases used in an examination question paper. So I have some of them in this presentation. I'm not going to explain all those terms or words here. If you look at your study guide, as I said, they are there, so review them. What is going to be the format of this question paper, Computer Studies, for the ACS? How is the format of the examination question paper for April, August, and November examination? There is going to be a section where you are going to ask to explain certain computer terms. certain computer terms such as video conferencing, expert system, computer virus, memory, RAM, ROM, simulation phishing. These are terms that are often used in computer studies environments. So, in this section, what is expected of you? You see a word or a term written, for example, ROM. So you are expected to define, to explain what it means. Okay? This section carries 2 marks each for every term that you explain. As I said earlier on, this is not a scope, but a guide. So those are these examples that you can see in my presentation, like video conferencing, expert system, computer virus, memory, ROM, RAM, supercomputer simulation. Mr. Edo is not telling you this is what you are going to see, but these are kind of terminologies that we can ask you to explain. So don't think these are the ones that should be there or will not be there. Well, it's possible they are there. So don't restrict yourself to one particular area. Okay, which other type of questions are you expected to see? Apart from the definition of terminologies, you are going to see a variety of compulsory questions of variable marks value, which is going to require you to explain in detail, to discuss in detail. Where do we get this question from? As I said, from the whole of your syllabi, the module, all the units will be covered. So apart from the definition of terms, you are going to see compulsory questions for you to explain, to discuss, to differentiate in your examination. Your examination in computer study, there will be a compulsory program writing. So you'll be asked to write a computer program, to design an algorithm. That one is a must. It's a must. You cannot go to the church in the Catholic and say you're not going to take Holy Communion. It's a must. So I will ask you to write a program for me. I will ask you to design an algorithm for me. So in this presentation, what I'm going to do, apart from telling you the format of the examination, I have selected some topics which I'm going to discuss with you, tell you how to answer questions that might or that can arise from them. So one of such topics that I have selected is algorithm and programming. I considered it to be one of the difficult areas in your syllabi, one of the difficult units in your course outline. So in order to help you in this area, I've selected algorithm and programming to explain to you in this presentation. So you are free to write your program or design your algorithm using any programming language. We are not restricting you. You are free to use any programming language. But I'm going to use Pascal. Now, what am I going to focus on here? First of all, we are going to see the structure of a Pascal programming language. The structure means the format it must be. Just like I'm going to build a house. Every house must have a foundation, irrespective of the type of the structure you are going to build. There must be a foundation. Every house must be developed. Every house must have a roof, irrespective of the type of building it has. There must be a foundation. There must be a roof. These are necessary, compulsory things that must be in every house. Then in every computer program, irrespective of the language being used in writing that program, these following things should and must be there. And what are they? Those ones that, if you look at the screen, there are these words that I bold, that are bold. The first one you can see there is program. Meaning, if you're going to write a computer program, for example, in Pascal Programming language, the first thing I will expect you to write for me is that word program. Now, what does this do? What is the function of this in writing program? In front of program, you write a kind of the program name for me. Something like a title, let me put it that way. Something like a topic, what the program is all about. Let me give you an example. If I'm going to write a program to calculate student results, if I'm going to write a computer program that can calculate student results, so I can say program to calculate student results, program to add numbers together, program to calculate salaries. So the function of that word program in your program instruction is to give the program a name. All right? After that, what next comes is declarations. Declaration. Most of you taking computer studies have done it at secondary school level, which I presume. So as I begin to speak, you kind of remember now some of those things that you were taught at your secondary school level. Now, what's what we call declaration after program. You have declaration. What are we going to do? What is declaration? Declaration is to tell the computer the type of variables that the program can accept or should not accept. You declare it. You see, if you travel at times at the airport, the custom will tell you, do you have anything to declare? Do you have certain things on you you want to tell us? So if we see them on you, it's not a surprise. Okay, custom, I have 1,000 US dollar. Custom, I have fish with me. Custom, I have an iPad. So if after I have declared what I have, and the custom searches my bag and finds them, it is no longer an offense. Already I've declared them. But if I don't declare them and the custom officer searches my bag, then it becomes a problem. So how does that relate to what I'm trying to teach you here? There are certain values or labels that a program should expect to have or to accept. So you must tell before the program starts, listen here, Mr. Program, these are the type of data I'm going to use. So the program knows already. You have declared them. So the declaration section of your program takes care of that. You declare your constant, you can declare your variables. You know, I want you to understand the difference between a constant and a variable. The values of variables can change during the lifetime of a program. The value of a variable can change during the lifetime of a program. What is it Mr. Edo is talking about here? Let's look at some things that can be referred to as variable. For example, if I say account balance, your account balance can never be fixed. It varies. Today I can have 500 Namibian dollars in my account. Tomorrow I can have 1,000 Namibian dollars in my account. In the next 2 minutes I can withdraw 200 and it's left with 800 Namibian dollars in my account. You can see my account balance is variable. It varies. You see, it varies. It is not fixed. Do you understand that now? Whereas we can talk about certain things that are constant. The values are fixed. Now, if you talk about a constant, an example is the account name. The name of my account is Edo. It's fixed. Unless perhaps if I change my name, which is not, most times it's not possible. It's fixed. So if you say account name is Edo, it's fixed. So it's a constant. So constant will never change during the lifetime of the program. Variables will always change during the lifetime of the program. So you have to tell a computer program that, listen, these are going to be constants. Salary is going to be constant. The number of hours I'm going to work, it varies. It's a variable. Today I work 2 hours. Tomorrow I want to work 4 hours. That is a variable. So you have to define that. So in your declaration, declare your constant. Tell the computer program what your constants are. Tell the computer program what your variables are. Those are the things you do in variables declaration. As this presentation continues, I'm going to talk more about declaration. Then after your declarations, you have what is called the statement. The statement. The statement means the instructions in the program that get things to be done. The statement are the instructions that you give to the program to have things done. You know, a computer is an idiot. It's not a human being. It does what is being told to do. A computer will always do what is being told to do. So you tell a computer what to do. How do you talk to a computer? Hey, computer, print in red. Hey, computer, print in black. So under your statement, the statement section, that is where you give an instruction to a computer that this is what you should do, and this is how you should do it, and this is when you should do it. So all those instructions that you give to a computer now falls under the statement. As you know, as a computer student at secondary school, you should know that there are different types of statements. So if you look at these formats that I have here, you see program, you have declaration, you have statements. Before you now on the screen is a simple computer program that uses the programming structure of Pascal. Can you have a look at the computer program in front of you? Now let us go back to our structure now. What is the first thing I have here? What is the first thing? Can you see? Program. So if in your April examination, in your August examination, or November examination, you see a question in computer studies that says, write a computer program that can add 3 numbers together and calculate the average of those numbers. Question. I want you to write a computer program that can add 3 numbers together. After that, the program should be able to find the average of those numbers. That is what I want the computer program to do. How are you going to write it? The first thing you should write, as you can see on the screen, is program. Then what should be in front of the program? Give it a title, a kind of a topic. You can say program to add 3 numbers, using the example that I'm talking about here. Program that can calculate average. Program that can add numbers. It depends on you. Nobody will say you are right or wrong. But let what you are going to write has a relationship, a meaning with what the program is all about. What do I mean? I cannot be writing a computer program to calculate wages, then I will say a program to calculate simple interest. No. Let the topic, otherwise what you are going to write in front of the program has a relationship with what the program is all about. Are you with me? Yes. Pay more attention now. Can you see that after the program, what next? Declaration. If you look at the structure I told you before now, I said after program you have declaration. Then I told you 2 things you should declare: constant, variable. If you look at this sample program, what is it that is being declared here? Variables. A program might not have constant. A program might not have variable. It depends. That is where your critical thinking, your logical thinking comes to be. It is left for you now to determine, oh, is this value a constant? Is this value a variable? That is where you have to think now yourself. That is where critical thinking comes. No wonder some students run away from programming, because it involves critical thinking here. Let me give you an example. If we talk about skin color, is it a constant or is it a variable? Skin color. Can I be black today, then tomorrow I become white? No, it's constant. It cannot change. That's where you have to think now. It cannot change. Now let's think about something else that can change about you now. Let's think about the height. When you are growing as a boy, as a child, you can see your height continue to change. It's a variable until you get to a certain age. So talking about variables and constants, that is left for you to determine. Oh, this value is a variable, or this value is a constant. Now this program that is in front of you, what does this program do? This is a program that can ask two numbers from you. After asking the two numbers, the program will add the numbers together. After that, the program will print out the sum of those two numbers. That is what the program in front of you can do. So in my variable, I'm going to declare to the computer now. So when you are declaring your variables, just write VAR, variable. Then you tell the computer what your variables are. You give them your variable's name. You can give any variable's name. I want to add two numbers together. So I tell the computer, please computer, there's going to be the first number which I call num1. There's going to be another number which I call num2. It's not necessary you call it num1. Somebody else can say n1. Some can say first number. Another person can say second number. I just decided to say, let me call it num1. So you can use any variable name. So I've told the computer in my declaration here that num1 is a variable, meaning the value can change. My number 1 today cannot be number 1 tomorrow. Might not be number 1 tomorrow. Num2, the value can change. Now, why is sum? A question here I want to ask you. Why do you think sum is also declared as a variable? Can you think? Why do you think is sum also declared as a variable? Why? Remembering what a variable is, the value can change. Yes, sum is also a variable. Do you know why? If the numbers can change, then the sum can change. Remember what the sum is the addition of the two numbers. So if I change the two numbers, what is going to happen to the sum? It will change. So if my first number is 1, my second number is 2, then my sum is what? 3. What if I change the numbers? My first number is 2, my second number is 3. The sum will be what? 5. So sum in this program is also a variable because it can change. It depends on what I enter as my numbers. That is why it's declared as variable. Then in front of the declaration, can you see this word in bold called integer? I declare num1, num2, and sum as my variable. But what type of variables are they? Are they numbers? Or they are alphabets? If my variables are numbers, then we'll tell the computer integer. So the word integer here is telling the computer that, listen, Mr. Computer, these numbers, they are integers, meaning they are numbers. If, for example, I have a variable and the name of my variable is name, that is a label. Can you see that? That is an alphabet rather. That is an alphabet. It's an alphabet, so I cannot say integer. Can you see that now? So this word integer here tells the computer that these variables are integers. I want you to remember again the structure of our programming language in Pascal. Program, variable declaration, then you come to the statement. Let me go back a little bit. Can you see where the statement is? Now that is where we are going to now. Remember what I told you earlier on in this presentation. I said the statement, this is the section where you tell the computer what to do, when to do it, and how to do it. So in the statement section in Pascal, we always start with this word, begin. So in between begin and end, there is what you see. You tell the computer what to do, how to do it, and when to do it. In between begin and end. So computer, let's start. Now, how do you talk to a computer now in Pascal programming language? Remember, this is not a human being. You are interacting with a machine. I want now to explain to you some of those statements that we use in Pascal programming language. The first one I will explain to you is write. Write. I think I have it also in this presentation. If I can quickly scroll there to make it faster as this presentation continues. Okay, this one is okay. Yes, I have it here. Right. Right. Let me explain to you what this statement does. This statement gives an instruction to the computer to write on the screen. You know, it's not a human being. So if a computer is going to talk to you, it's going to write it on the screen. If you are going to talk to the computer, the same thing now. So, for example, I can say write. Okay? Then if I say write, I open a quote. I'm going to explain. I wish I have enough time to really demonstrate a lot to you about programming. It's one of my favorite topics that I so much love in computer science, the writing of programs. I want to go back to that program quickly so that I can show you something that I'm about to demonstrate. Because as you look at it while I demonstrate, it makes it more real to you. Say write. Okay. Remember what I said. Write gives an instruction to the computer to write something on the screen. So if, for example, I say write, then I say, tell me your name. Okay? Tell me your name. Do you know what the computer is going to do? On the screen, when this program is going to be executed, it will just write on the screen, tell me your name. Then the computer expects you to type the name. You see now? So, let me use something that will make it real to you. Let's take our mind to the ATM machine. Whenever you get to the ATM machine to withdraw money or cash, what happens on the screen? Once you insert your credit or your debit card, a question will come to the screen and says, enter your PIN. That was the instruction the programmer wrote. So what the programmer did then was, he says, the programmer wrote, enter your PIN. That is what the programmer wrote, the person who wrote that program. Enter your PIN. So you see that on the screen. So you use the right to write an instruction that the computer is going to ask the user of that program. After you have written write, Then in front of write, you write what the computer should ask the user of the program. At the end of every line, you must have this semicolon. Can you see? Can you see from the beginning of this program? Program at the end, semicolon. Variable, semicolon. Can you see that now? Write. Input number 1. So here the computer is asking the person, enter number 1. That is, enter the first number. Then you can see something under write, which is called read. The read is a statement that now reads the number that you have entered, or that reads the variable that you have entered into the computer. Let me explain the difference between write and write line. The difference between write and write line. If I write something like this, write A, B, C, then I have write line A, B, C. Let us look at the difference here. Write A, B, C. Another one, write line A, B, C. The first one, the computer is going to write your answer in a horizontal way. So when the computer is going to write the first answer, it's going to write like this, A, B, C. Do you understand that now? It's going to write A, B, C. But the second one, do you know what the computer is going to write? Write line is going to write like this, A, B, C, in a vertical way. Write line, meaning after writing the first variable, the next variable should come to the next line. The next variable should come to the next line. Write line. So the difference between write and write line is write line will write your variables in a vertical manner, as you can see, while write will write your variables in horizontal manner. Before I leave this slide, I want to emphasize on something. Again, start your program with program, put a kind of a title, a topic for that program, declare your variables or your constant. Tell us if the variables and the constant, they are integers or they are not integers. Okay? Then you begin writing the real program. Whenever you want the computer to ask the user for something, use write. If you want the next question to be asked in the next line, use write line. That is what I've just explained, the difference between write and write line. At the end of all your instructions, you should have end with a full stop. That is the only place you have a full stop. I want you to go, sit back, and look at this program and see the format it has taken. Let us discuss more about some of the things I have used in this presentation. I talk about integers, for example. An integer is a whole number. You know what a whole number is, as we are taught in primary school? Numbers that have no decimal point or they are not fractions. Your integers can also be real, that is those numbers that can be fractions or they have decimal points. Okay? Then we have character, which is alphabets, numeric and miscellaneous symbols. What is Mr. Edo trying to tell you here? What I'm trying to tell you that when you talk about your variables, there are different types of variables. Because the other time I told you that your variable can be integer. Then apart from integer, which other type of variables can you have? You can have real, you can have character, you can have Boolean. Let me illustrate. If I say 1, 3, 4, these are integers, variables. They are numbers without decimal points. If I say 2, 4, 1 over 2, these are real integers. I mean, real variables. They can have decimal point, they can have fractions. If I say Edo, name, these are variables, but they are character variables. And there are times where a situation, something is going to be either yes or no, true or false, then it becomes Boolean. When you have yes or no, true or false, then it becomes Boolean. So in this area, you have to look at your variable and say, where does it belong to? Is it an integer? Is it real? Is it character? Is it Boolean? Then you declare it as such. This diagram on the screen explains to you how variables works within the computer memory. But I'm not going to spend much time on that. Okay? So I've told you how you should declare your variables. But something that you must avoid, something that Pascal Programming and most programming languages does not accept, is the way you write your variable names. The way you write your variable name. A variable name should be written together without a space. For example, when we say first name, I want you to use this word first name. This is not allowed as a variable. There must not be a space here. There must not be a space. It's either you write it together or you use an underscore in between them. Just have written on the screen and examples of accepted variables name and examples of variables name that are not accepted. Go back to your study guide and look at various examples of variables names that can be accepted and examples of variables names that cannot be accepted. We are gradually running out of time, but I will use the very few minutes left to tell you a little bit about constant. I've told you that a constant will never change. The value of a constant will never change during the lifetime of a program. All right? Let us look at something else apart from writing a program properly. Then in writing your program, please don't forget the type of symbols you can use: your addition, your subtraction, your multiplication, your division, your mode and div. Please, they are all in your study guide. I will advise you go through them. Let me spend a little bit of the few minutes left on the use of certain statements in computer programming. Let me talk to you about the decision-making section of your programming. For example, we have the if, then, we have the if, then, else. I'm sure you must have come across this at your secondary school level. When you are going to write a program and you get to a section where a decision is supposed to be made, you can use either of these: if then or the if then else. The if or the if then else. What does the if then does? The if then, here, this is how it works. If there will be a condition in front, you write a condition in front of the if. What the computer should do if the condition is true should be written after then. Should be written after then. Let me write a very small program for you in that aspect. Let's say A is equals to 4, B is equals to 5. Look at it. And I say if A is less than B, then C is equals to A divide by B. You see, C is equals to A divided by B is not going to happen automatically. It's going to happen depending on this condition, whether it is true or false. So what the computer does here is that it tests this condition. If the condition here is true, then this is what the computer will do. If the condition here is not true, then the computer will ignore this. So let's look at it now. What is A? A is what? 4. What is B? B is what? 5. So I'm asking, is A less than B? It's a question. Is A less than B? True. A is less than B because A is 4, B is 5. Because it is true, what will the computer do? Then it will use 4, which is the value for A, to divide 5, which is the value of B. But if this statement is not correct, then the computer will ignore this. So you use the if-then statement to make a decision whenever you come to such an area. We have the if-then else also in a programming. Practice on it. On the program on the screen, I have few examples of the if-then else statement. We have the looping statement. A looping statement is a statement that makes a computer program to repeat certain set of instructions over and over. It's a statement that makes a computer program to repeat certain set of instructions over and over, such as the while do, repeat until. These are looping statements. So practice how to use all these looping statements also. Don't also forget what your flowchart is and the various flowchart symbols. You should be able to draw them, should be able to label them, and how to use them also. Then again, if you are given a flowchart question to complete a trace table, please revise it, how to use a flowchart question to complete a trace table. I've just guided you on some things in computer studies, in the Advanced Certificate in Secondary School Education for April, August, and November examination. Mr. Edo did not say what I discussed today is the only thing that will come out in the examination. I've guided you. There will be a variety of questions for you to answer, to discuss, to define, to explain. There will be a section for you to just define. There will be a section for you to write a computer program. There will be a section for you to draw a flowchart. There will be a section for you to complete a trace table using a flowchart. There will be a compulsory section, whether you like it or you don't like it. It's a must. It must be there on Microsoft Excel. There will be a compulsory section also on Microsoft Access. These are compulsory in computer studies. Those things that I said you must going to see. Apart from those definition explanation, there will be a program writing. There will be a question on Excel. There will be a question on Access. There will be a question on algorithm. There will be a question on flowchart. And finally, there will be a question on how to design an interface screen of a computer system design. These and many others you should expect in your examination. But do you know what? If you don't start to prepare today, then there will be a problem. Start your preparation today. Along the line, you might encounter one or two problems. Please call me on the number displayed on the screen or email me as displayed on the screen. Then I can assist you to prepare for the examination. I wish you all the best in your examination in 2008. In case you fail to meet up in April, try August. If you fail to meet up in August, try November. The Bible says a righteous man can fall several times, but he will stand up and continue to walk. Don't give up. Thank you.